In an ideal world, cars and trucks would be 100% emission-free. Unfortunately, they aren't. The reality is that pollution from vehicles is frequently above legal limits. This impacts our climate and the health of millions of people, especially in urban areas. The need to act is urgent, yet laboratory tests by themselves to determine emission levels have proven inadequate. So we need new technologies and new policy approaches. And that's where remote sensing comes in. Remote sensing is proven technology that has evolved considerably in recent years. It gives researchers and policymakers insight into transportation's true contributions to air pollution. This can lead to more effective policies, because if you know the facts, you can act on them. So what exactly is remote sensing? Remote sensing measures exhaust emissions from vehicles in normal, everyday driving. The equipment can be set up above or alongside a roadway. Using a sensor and light beam, it measures pollutant concentrations in the exhaust plume as a vehicle passes. A camera records the license plate. This can be used to look up make, model, and other specifications such as fuel type and engine size. Another device measures speed and rate of acceleration. Meanwhile, sensors measure ambient conditions such as temperature, barometric pressure, and humidity. A remote sensing setup can record thousands of samples a day. That much data can provide a good picture of vehicle emissions at the location, including the concentrations of specific pollutants. And that's just the beginning. When you combine remote sensing measurements made at many different locations at different times of year, you can construct a very detailed and instructive picture of how and where pollution is occurring. For instance, you can gather data on the emissions of cars of brand X, Model Y, with a gasoline engine built in 2015. Are real-world emissions from these cars in line with laboratory limits? Is their emissions performance better or worse than similar vehicles made by other manufacturers? Valuable data. A good example of how valuable is London. Remote sensing data helped reveal that nitrogen oxide emissions from the iconic black taxis were 7 times legal limits and far exceeded other diesel passenger cars. That's the kind of insight that can be useful to policymakers determined to improve air quality. Remote sensing isn't a silver bullet, but it is a practical and cost-effective technology. Combined with laboratory testing and other techniques, it can lead to a clearer understanding of air pollution from on-road transport and better policy options. It takes us closer to our goal: improve air quality in cities all around the world.